As we have discussed in the previous classes, that transfer function is a important mathematical model for control systems. We have discussed in the previous class that how to obtain the transfer function for a given electrical system. That components of electrical systems are passive RLC and active components voltage source and current source. We have also discussed in the previous class when differential equation is given, a system is described by differential equation, then how to obtain transfer function. Laplace transform is a tool which transforms a complex differential equation into simple algebraic equation. So, how to obtain transfer function when differential equation is given, also couple of problems we have solved. Today we just focus on mechanical systems and classification of mechanical systems and how to obtain transfer function for a given mechanical system. Basically, the mechanical systems are classified based on the motion involved in it. Translational motion means linear motion. We can say that mechanical translational system which has a linear motion, linear displacement, linear velocity and acceleration. The examples of translational motion mechanical systems are car, bike, bus, electric train, etc., which has a linear motion. Whereas rotational motion mechanical systems are which has fixed axis rotation. It may be a motor, it may be a floor mill, it may be a fan. Fan also comes under rotational motion mechanical systems. So, we discuss one after the other what are the components of these mechanical systems and how to obtain transfer function. So, the components of linear motion or translational mechanical systems are mass, spring and dashpot. These are the three passive components of mechanical systems. What is mass? Mass is nothing but weight of a mechanical system. It is in fact spread across the body, but we assume that it is concentrated at the center of the body. It is given by this symbol M, and when force is applied on a mass, then it will have a displacement x, linear displacement x. Then the opposing force due to mass, according to Newton's second law of motion, it is m d square x by dt square, where d square x by dt square is an acceleration. So, this is the force F applied. So, according to Newton's second law of motion, F is given by m d square x by dt square. The second component of the translational mechanical system is a spring. It is represented by like this, and the spring constant, spring stiffness is given by K, and when force is applied on a spring alone with some reference other terminal, then it will have a displacement x. Now, the elastic deformation in a body is given by this spring force. So, the spring force, the opposing force due to the spring is given by spring constant and displacement. So, this is another component of a mechanical system. Spring is that indicates actually elastic deformation of a body. Now, if the spring has two terminals, two are subjected to different displacements, say x1, x2, then when force is applied F, on a spring. Unlike the previous one, the other terminal is connected to the reference, but here the opposing force due to the spring is k into x1 minus x2. This is the opposing force due to the spring in mechanical translational system. There is another component that is actually called dashpot. It is related to friction component. This dashpot is represented by which has a friction coefficient of b, and say the displacement is x when force is applied F, then the opposing force due to the friction is proportional to velocity. So, that force is given by b into dx by dt. So, you can see that there are three components. First component will have an acceleration term, and the second component has velocity term, dashpot, friction, and the third component, spring, has displacement term. So, when I say x is the displacement, x dot is velocity, x double dot is an acceleration. So, all these three are passive components of translational mechanical system. You can represent a mass like this, and a force is applied on a mass, then a simple mechanical system I have represented like this. All three components are involved, m, b and k, and a force is applied on it. So, we can develop an equation according to Newton's second law of motion, that F is equal to applied force is equal to reaction forces. One is due to mass and the other one is due to friction, and the third one is due to spring. This is the equation. So, this equation is being written according to Newton's second law of motion. I must indicate something about dashpot. Dashpot is a component, it is a piston moving inside a cylinder. That cylinder is filled with viscous fluid. Dashpot is intentionally used in a mechanical system to have smooth linear motion. Please do remember that when I say an electrical system is good, you will say only when resistor, inductor and capacitor. If you take the example of fan, if all three are with a proper values, then whatever input you give, it will produce the desired proper output. So, we can say that system is good when all the parameters are within the limits. Similarly, in mechanical system, all three passive elements should be properly designed so that you have a comfortable motion. As you know, when you are traveling in a bus or car, when speed breaker comes, as you know that bus will have some kind of vibration, but still the passenger in the car or bus will be comfortable, smooth, then only when all these three elements are properly designed. If shock absorbers, you are aware of shock absorbers, and if they are not properly designed, then you may get a back pain. So, I say that a translational mechanical system is smooth without any vibrations and interruptions only when these three components are properly designed. So, friction is intentionally created sometimes, otherwise that exists between two solid surfaces, solid and liquid surface. Like friction is classified into three components: viscous friction, static friction and Coulomb friction. We will not go into the details of various frictions that exist in mechanical system, because our aim is how to obtain a transfer function when mechanical system is given, because we are confined to transfer function only. Let us consider one example. Of one mechanical translational system. Look at this, this is a reference, say ground, and this is the mass of tires. If you consider an electric mechanical system, automobile system, it may be a car or bus, then body of the car. So, you can see that when you are in a car or bus, it has a body, then there exists between some elastic deformation between the tires and body of the car, and this is the spring stiffness and this is friction. That friction exists between the tire and the ground, and this is elastic deformation that exists between the tire and ground, and this is K1 that exists between two masses. So, always you remember every mass is associated with certain displacement. Say this is a mass having a displacement of x1. When force is applied on it, when force is applied on a mass, then it will have a displacement x1, and the displacement of mass 2 is x2. So, this you should keep in mind that mass is associated with some displacement. So, certainly force is applied on mass 1 here m1. Now, you may be asked to find out the transfer function. That transfer function may be x1 of s by applied force or x2 of s by f of s. x1 and x2 are linear displacements. They are the output of mechanical system here, and f of s is the force that is applied to the mechanical system, is the input. So, you can obtain any one of those, or you can obtain both when this simple mechanical system is given. So, how to write equations first? So, before getting the transfer function, as I was indicating in the previous class of electrical system, there we need to apply KVL or KCL to write the voltage or current equation. Similarly, here we need to write equations of force according to Newton's second law of motion. So, let us redraw this diagram for convenient way. There are two ways to solve this problem to find out the transfer function. One is to draw the free body diagram, or we can convert this mechanical system into mechanical circuit diagram. What is that mechanical circuit diagram? So, here you have two displacements x1 and x2. Let us indicate that x1 and x2, you call them as two nodes. Now, what are the components that are associated to the mass 1 or displacement x1? So, this mass 1 is connected to the node x1 and then ground. So, let me connect that mass which is associated to the displacement 1, then ground, and this friction also exists between x1 and ground, K also exists between x1 and ground. So, these components are also connected to the displacement x1. all three, mass, K, friction, are connected to displacement x1, and of course there is a force also applied on a mass 1. So, this is also can be represented like this F. This is K, this is B. Now, you can see that this is the element spring K1 connected between two x1 and x2 nodes. So, there is x1 and x2 here. So, let me connect K1 and K1 between x1 and x2. Now, there is a mass m2, its associated displacement is x2. This is the way you can redraw the circuit. As you can see now, it looks like an electrical circuit, because we are familiar with the electrical or electronic circuits. So, the same mechanical system is being drawn as a mechanical circuit diagram, which has two nodes and every node is associated with some displacement. Now, how to write equations? So, you can have now the force equation at node 1, which has displacement of x1. So, I can write that force according to Newton's second law of motion, applied force equal to reaction forces. So, all three reaction forces, first m1, it is associated with x1 displacement, then there is a friction component B dx by dt, its velocity, then K with respect to ground, K x1. So, all these four components are covered here, and there is another component K1 is also connected to x1. So, what will be the reaction force due to K1? K1 into x1 minus x2, because two terminals of K1 is associated to two different displacements. So, it is written as x1 minus x2. Now, once this equation is written according to Newton's second law of motion, then you need to apply Laplace transform. So, apply Laplace transform, you can get f of s into m1 s square x1 of s plus b s x of s plus k x1 of s plus k1 x1 of s minus x2 of s. So, application of Laplace transform we have already discussed. If it is a d square term, you have s square. If dx by dt, it is s into xs. That way the Laplace transform is applied, and I can say that this is a algebraic equation and this is a differential equation. So, now you separate the terms of x1 of s and x2 of s. m1 s square plus bs plus k plus k1. So, these are the coefficients of x1 of s and plus x2 of s, you have only minus k1, Similarly, you can write now equation at node x2. There are two nodes, so it is like nodal analysis. Here also you have got now two equations. At node x2, you need to write the second equation. You can see what are the components that are connected to the node 2. Now, you can forget about all this. x1. So, only two components are connected to x2. One is mass 2 with respect to ground, and the other one is k1 with respect to x1. So, it is a simple equation at node x2 you get that m2 d square x2 by dt square plus k1 into x2 minus x1. One important observation you could make here, in equation 1, same reaction force due to k1 is appearing as k1 into x1 minus x2, and here it is x2 minus x1. The reason is, when you are writing equation at node 1 x1, we assume that x1 is dominating x2. When you are writing second equation, we assume that x2 is dominating x1. So that's why you have a displacement difference x1 minus x2 in equation 1 and x2 minus x1 in the second equation. So there is no force applied associated to the displacement 2, so it is 0. Now you apply Laplace transform, to this, this way. Now you can actually separate the terms of x1 of s and x2 of s, m2s plus k1. So you have got now this, you can call equation 1, this you can call as equation 2, and using these two equations you can actually get any one, either x1 of s by f of s or x2 of s by f of s. Suppose if you write from this equation x1 of s from this, x2 of s into m2s plus k1 by k1. So from this second equation you can get x1 of s equal to some term, that term you substitute in the equation 1. So call this as 3, substitute 3 in 1, So in place of x1 of s, if you substitute this term, then you will get two variables. One is f of s and the other one is x2 of s, and get the transfer function x2 of s by f of s. So this is the way, when mechanical system is given, you should able to find the transfer function. Yeah, consider next example. It's like an electric train. You can assume that one mass is engine, the other mass is a coach. You can see the wheels of the coaches and engine. There exists a friction between mass 1 and then ground, and here also the friction exists. This B1, B2 is a friction components, and this B12 is a dashpot that actually exists between the two masses. As you know very well, when the train moves, it should have a smooth motion once again. Passenger should feel so comfortable. So the design of K1 and B12 is very, very important, and you might have seen between the engine and coach there exists some deformation, spring parameter, and also dashpot. These two makes that there will not be any discomfort for a passenger traveling in a train. So similarly, K2, K1 and B12, all that takes responsibility of having smooth motion in this particular example. So B1, B2 anyway, it exists like a friction, and it is a loss component actually. So the energy is lost due to friction in a mechanical system. It is similar to resistance in electrical system. Anyway, a force is applied here on mass 1, and x1 is the displacement associated to mass 1, and x2 is the displacement associated to mass 2. So here also you may get a question that determine the transfer function between output x2 of s by f of s or x1 of s by f of s. Whatever may be the output parameter, one should able to write the equations using Newton's second law of motion. That is very, very important in a mechanical system. As we are not comfortable with the mechanical system, it is always good to draw its mechanical circuit diagram. As I was mentioning that there are only two displacements, that number of displacements must be equal to number of nodes in a mechanical circuit diagram, x1 and x2, and then what are the elements that are associated to x1 we need to represent. So, there is a mass 1, and then there is a friction that is represented by a dash pot B1, and a force is applied this is an active element of a mechanical system, and you can see now K1 and B12 are between two masses, means two displacements. So, K1 B12. Now, for the second node x2 there is a mass 2, and then there is a friction component represented by dash pot, and then there is a spring also K2, it exists between mass 2 and ground. So, it exists between x2 and ground. So, this is ground, this is ground. Now, almost all the components are covered. It looks like an electrical circuit. It is a mechanical circuit only because all mechanical components are involved. Now, writing the equations, as I said, at node x1, all the elements that are connected to node x1 are to be written here using Newton's second law of motion. So, for convenience, what I do here, all the elements connected to x1, 1, 2, 3 and 4, 5. So, the rest of the circuit better I disconnect. Now, you can see that 5 terms should appear in equation 1. So, F is equal to, this is the applied force, equal to m1 acceleration term and friction term, and these two are associated to two displacements. So, plus B12 that exists between two displacements. So, difference in the velocities x1 dot minus x2 dot, and K1 is also there, K1 into x1 minus x2. So, once this equation is being written, the next step is you need to apply Laplace transform. Whereas, now coming to the second node, at node x2, you need to write the equation now. So, connect them back. Now, you can just forget about the other components that are connected to x1 alone between x1 and ground. So, this will be the circuit for writing the second equation at node x2. There is no force directly involved here. So, it is 0, no applied force on mass 2, but the other components you need to write m2 into d square x2 by dt square plus b2 x dot x2 dot plus k2 x2. So, these are the components connected to x2 and ground, and whereas these two components is b12 x2 dot minus x1 dot plus k into x2 minus x1. 70% of the problem is complete once you have written the two equations at two different nodes using Newton's second law of motion. Then the rest is a routine procedure. Apply Laplace transform to both and get the required parameter. It may be x2 or it may be x1 with reference to the force you need to find the transfer function. So, once you are familiar to develop the equations and obtain the transfer function, any kind of question that appear on mechanical system can be solved.